Now we mentioned secure boot. Secure boot actually works in conjunction with the TPM chip on UEFI systems to check the integrity of all the system files before allowing the boot process to proceed. It's just an on or off thing, and on UEFI systems it is typically on by default. And it's no big deal as long as somebody didn't modify something. What do we mean by modify? Well, think of a hard drive, okay? So what if I walked up and I opened up a computer and removed a hard drive? It's 4 screws and a couple power cord and a data cable. Not that hard to do. So what if I stole a hard drive? And now I have a hard drive that's got Windows on it. I'm going to put it into another computer and I'm going to try to boot to it. Or I'm just going to put it in another computer that already has an operating system and I'm going to try to access it. Secure boot and along with BitLocker would not allow that to happen. As soon as the hard drive is stolen, it's in an encrypted state. It's no longer even decryptable, because the keys were stored on the TPM chip. That's one thing. You could also have the kind of conversely, let's say I booted a system up to a Linux distribution that just runs off of a DVD, which those are out there. And then I'm using that to try to access the hard drive. Well, therein lies, a situation where the startup configuration has changed. And then it's going to enter into a recovery mode and secure boot's going to ask me for more information. The other time you're likely to see this is if you need to boot a machine to a DVD. Okay, now I just mentioned Linux distros. We've also got antivirus rescue disks that can be put on USB or DVD, and you boot up to do an antivirus scan while the operating system isn't active. If they don't boot, good bet is to get into the UEFI interface, or configuration, I should say, and turn off secure boot. You need to put it on legacy boot just temporarily so that you can actually get it to boot up.